friends, I will continue with the history of non-ferrous metals. Now, in the last lecture, I had shown a slide which said that up to about 5000 BC, we had Paleolithic or Old Stone Age. Then there was the New Stone Age, where settlements began to appear, and then around 3500 BC, we had the beginning of ancient civilizations in Egypt, Mesopotamia, Indus Valley, and China. Now, I also mentioned last time that copper seems to have been discovered rather accidentally when the malachite, that something that which is CuCO3 CuOH twice, which the Egyptians used for eyeshadows, thinking it has miraculous properties, and they were not very wrong. Actually, it is beneficial to the skin also. If some malachite falls into fire where there is carbon, then copper will be produced, because copper oxides will be reduced. So, they must have found this accidentally, and then they learned by trial and error how to make large quantities of copper. Now, if copper contains some tin ores, then tin will get oxidized along with copper, and you produce bronze. So, they started producing bronze also. Now, in ancient times, very often they could not tell exactly what was in an alloy. So, they sometimes would have called it superior copper or soft copper or hard copper, but definitely they learned to make bronze. So, we had Stone Age, Copper Age, then Bronze Age. Now, the familiarity with metals started with gold, because gold is found in native state, with copper, because copper is also found in native state, and also it came out of this ore accidentally, as I mentioned. Silver, which actually occurs with gold, and then lead, tin, they must have also come from accidental reduction of oxides by carbon. Mercury came a bit later, because an ore of mercury, HGS, if it is heated, it decomposes, produces mercury. So, somebody must have accidentally produced mercury. Iron came in the scene around 1500 BC, and there is a very interesting story about how iron may have been found. In India, there are stories amongst many tribals that what happened actually is that deep in the woods, some hunters chased a small animal, which could have been a rat or a rabbit or something, and that animal jumped into an anthill. Anthills are common in forest areas, which are about 5, 6, 8 feet high, which happened to have a hole on top, and many of them have a hole on top. So, it jumped into the anthill, and now to catch it, they put a stone on top of the anthill and covered all the cracks, etc., with bushes, and they put a log through a hole and set a fire. They put some holes here and there for the smoke to come out. So, they thought either the animal will come out and they will catch it, or it will get roasted alive inside. Now, their story is that there was a wind blowing at that time. So, the wind helped the fire, and there was a draft that came, and the fire went on, and there was a surprise for them when after a few hours they did not know what to do. They left it there. They thought the animal was completely roasted and ruined anyway. So, they left it, and they say next morning they found there was a metallic mass inside, which was very hard. What was this metallic mass? What might have happened is that ant hill was in an area where there was iron ore, and there was a lot of carbonaceous metal inside, and when they set that in fire, there was a reduction. The carbonaceous material reduced iron ore to a spongy mass, a kind of sponge ore. This story sounds very plausible, because even until 18th century, the tribals were making this kind of iron in small blast furnaces, which were not very much taller than ant hills, maybe 5-6 feet high only, almost a similar shape. And the idea was the same, that you have iron ore and you have charcoal and you put some fluxes, so the slags come out. And iron is not totally molten, but it is semi-solid. So, you get what we call as a spongy mass, which had to be beaten for the slags to be separated and the metallic mass to be consolidated. So, this is the story that the tribals say, and the traditional iron producing furnaces, which continued in India till the 18th century, uses were only 1 meter high, traditional iron producing furnaces, about which I have given you some data a little earlier. Only about a meter high. Two-thirds of a meter in dia. They will be filled with iron ore, charcoal in a number of layers. This is what they would do: ore, charcoal, ore, charcoal, and they had a bellow here, that somebody will jump up and down and put the bellow, so that the air would be forced in, and they would get temperatures about say 1000 degrees, 1100 degrees, 1200 degrees. Not enough to melt iron, mind you, but they will get a semi-solid mass, from which, as I mentioned earlier, you have to beat and squeeze the slag out, and we call that iron wrought iron. Now, in ancient India, iron making centers developed in central India, Bihar, Bengal, Assam, UP, Rajasthan, Karnataka, and many of they were in forest areas where a lot of charcoal was available, and the tribesmen, many tribals became very good at it, and many of them are called lohariyas. And actually, some of these tribes became so good in making high quality wrought iron that the special names were attached to this kind of wrought irons. Like in Bihar and Bengal, there is a Munda tribe even now. So, in ancient times, the iron they produced was known as Munda Loha. So, that Munda Loha was a famous kind of sponge iron they produced. Now, this course is about non-ferrous metals. So, I won't talk about iron steel anymore. What about non-ferrous metals? As I mentioned, only 7 metals I have listed. I did not mention zinc, because zinc came into the scene much later. The only reason is very simple, that it is not very difficult to produce zinc by reduction of zinc oxide. You can take zinc sulphide mineral in an ore, if you heat it, it makes zinc oxide, and you can reduce it by carbon, produce zinc, but the zinc comes out as a vapor and it will escape. So, one has to learn how to condense the zinc. Now, Indians apparently learned them around 400 AD how to condense zinc, and they kept very quiet about it. The rest of the world did not know about it, and around 1000 AD large scale production had started in Rajasthan of zinc, and they learned to alloy, produce not only zinc, but brass by alloying with copper. But please remember, the first brass may have been produced not by adding zinc to copper, but by a process of cementation. Means if one takes ores of zinc and copper together and heat, you may end up with a brass, but that will not be very high quality brass. And to get high quality brass with high quantities of zinc, zinc has to be produced separately. Now, until about, as I said, the 10th century, only 7 metals were known. India only knew about zinc, which others did not know about, and that is how what it remained. It is only in the 18th century, till 18th century, we had these 8 metals or 9 metals, and aluminum could be produced in large quantities only after the invention of electricity in the 19th century. And that is how we came to Hall-Herold's process, and that was helped by the Bayer's process for Al2O3 production, which went into the Hall-Herold's process electrolytic cell. And from 19th century, then many other metals were beginning to be discovered. Like in the 18th century, when other metals began to be discovered that were like cobalt, platinum, nickel, bismuth, manganese, molybdenum, tungsten, zirconium, titanium, they came much later, only in the 18th and 19th centuries. 19th century, many more metals were added. Now, let us come back to the history of metal production, non-ferrous metal production in India. There are two kinds of historical evidence about the non-ferrous metal production in ancient India. One we call is literary evidence, and the other is archaeological evidence. Literary evidence obviously means the literature we have where there is mention of non-ferrous metals, and there is plenty of that. There are numerous texts starting with Rig Veda, Ramayana, Mahabharata, Charaka Samhita, Manu, Yagyavalka, Patanjali, Kautilya's Arthashastra. They all mention different kinds of metals. And there is of course also many visitors who came to India in ancient times, like we had Huinsang, the famous Chinese historian. We had Al-Biruni, who came later, and then we also have a Britisher called Colonel Todd, who wrote History of Rajasthan in the 19th century. So, these are some of the sources from which we get a lot of information. Now, as I had mentioned earlier, in Rig Veda the word ayas comes very frequently. Many people think it means iron, but there are other people who say not only iron, it also refers to metals as such, because they talk about red ayas and black ayas. Red ayas means copper, black means iron. Ramayana contains a shorter list of minerals and metals, but Mahabharata has many references to many metals, including iron, because by the time India had come into Iron Age, and it mentions iron extensively everywhere. There is description of many brass statues in the writings of Chinese traveller Huinsang, who visited India between 629 and 645 AD. He has written extensively about use production and use of brass in India. There is a special reason why brass became so important in India. Indians have always been crazy about gold. Now, brass was thought to be a kind of gold or a substitute of gold. So, brass had a strong attraction for Indians. As a matter of fact, there are stories that when some kings ran out of gold for whatever application they had in mind, like cladding of the buildings or making of statues, they asked for a substitute, and that was brass. And there are people who could make that. There is extensive reference to bronze and brass in the 4th century BC writings of Kautilya's Arthashastra. And Kautilya was said to be the mentor of Chandragupta Maurya, and after Chandragupta became the emperor, he went into his the other career where he wrote extensively, and Arthashastra is one of the books he wrote. There is in early 6th century BC writings of a very well known author called Barahamitra, and then most extensive descriptions of metals, alloys are found in writings of one man called Nagarjuna. This name you should know, you should remember. He was one of the most famous alchemists of ancient India, who lived from 166 to 2003 AD. He wrote a famous book, a text called Rasa Ratnakara, where he has described different metals and processes for making them. And he also is mentioned by many kings who actually invited him to come and produce the gold for them, because they thought he was producing gold even though he was making zinc. There are mentions of metals in writings of Charaka Samhita, 3rd century BC, of writings of Manu, Yagyavalkya, Patanjali, all of them before the Christian era. At that time, the word for bronze was kamsa, from which we today in Hindi we say kansa, and you know there was also the other words for brass was aratika, arakuta, ritika. Actually, ritika is derived from harita, means yellow. So, because it is yellow, it is called ritika. Some have written it, mentioned it also arakuta. And of course, you know that this zinc was called yashada. There are many Roman traders, and at that time there was trade between India and Romans. So, some Roman traders have written about use of metals in India. Some historians of Rome like Pliny, he mentions something called auri chalum, means golden copper, which actually referred to zinc. Colonel Todd, an Englishman who wrote a famous history of Rajasthan in 1829, actually have written very extensively about the metallurgical activities in Zawar mines, and a lot of credit goes to him for telling us, at least initiating the Indian historians to look back into the history of production of copper and zinc and lead in the Rajasthan area. And during the 13th to 17th century, there are records that Zawar mines were in full production till full production till 1760, and they were finally abandoned, because at that time Marathas were regularly attacking Rajasthan, and also the area got flooded. So, until then Zawar mines are producing copper and zinc, brass, etc. And during the 13th to 17th century, then an estimate says that 100,000 tons of zinc were produced, and there are very basis of these estimates. So, we had a thriving industry in zinc, and when that zinc was produced, it went into making brass also. Now, I mentioned about Nagarjuna. Nagarjuna, the alchemist in the 2nd century. Nagarjuna started it all. He is known as the father of brass. He wrote in his text Rasa Ratnakara that I have mentioned, that what wonder is that calamine, that is zinc ore, roasted thrice with copper converts the latter into gold. He writes, what wonder that calamine, that is zinc ore, roasted thrice with copper converts the latter into gold. So, this is the kind of process he was doing that. Now, you can make brass by adding copper and zinc, but this is not how the first brass was made. The first brass was made by cementation process. And the process is copper fragments, fine copper fragments mixed with roasted zinc, as Nagarjuna says, heated in a sealed chamber. (1000° centigrade) will produce zinc, because copper will replace zinc from the zinc ore, and that excess copper will dissolve zinc. But it so happens that by this process one cannot produce a brass which contains good amount of zinc. It will be 9-10%. It is a poor quality brass in many ways. Besides, below 950° C, no zinc is produced, even if all traces of oxygen is there. Above 1083°, copper will melt, and if copper melts, then the dissolution, the cementation reaction will not be so effective. So, the temperature has to be controlled in between these two, and our ancient the metal workers of Rajasthan had learned to do that. They could control so that the cementation reaction could proceed, and they were producing poor quality. Now, the golden color appears when zinc exceeds 10%. So, before that if people were making zinc brass elsewhere, it was not so attractive as when Indians started doing that. Proper brass will need zinc in excess of 28%, proper brass. This cannot be made by cementation, means cannot be made by heating copper fragments with roasted zinc ore. You have to prepare zinc separately and then make an alloy, which the Indians learned to do around 400 AD. This had become quite common actually by 6th century onwards, and then by 10th century it became a thriving industry in India. There is evidence, and this evidence comes from Huensang, that in Taxila there were huge structures made of brass, and today there are statues from brass vases from that era which contains more than 34% zinc. The Harappa civilization which thrived in north west India, that was 200 BC, the wide area. They were using all kinds of metal artifacts, and they had a famous port called Lothal, which is only 85 kilometers from Ahmedabad. Now, excavations have been made in Lothal and huge number of artifacts have been found. These are tools, weapons, personal ornaments, objects of domestic use, figurines, etc. And then we have found these things from all over India also. So, the excavations reveal that lot of evidence of metallurgical activities in ancient India, but Harappa is famous as a civilization for industrial and trading activities. They had connections through sea route, through land route, and they were producing all kinds of things. Some objects contained lead, pure copper ingots were there, 99.8%, that has also been found. What is difficult to say is that what was produced by ores collected locally or ores and concentrates imported through land route or through sea from elsewhere. Now, some people believe that you can tell whether the metal used in an object found at a place has been produced from a local ore or mineral by looking at the impurity contents. The idea is this, that suppose you find certain impurities in a figurine that you have found at one place, and if the same kind of impurities are there also in locally available ores and minerals, you may be tempted to think that the metal has been produced from that ore and mineral. But people have questioned this. There are many reasons to believe that this may not be true. What is true though, that many objects of brass or bronze that were made in India, certainly the metal and alloy must have been produced in India, there is no doubt about that. And much of these activities took place in the Aravalli hill region of Rajasthan, and there are many archaeological excavations have found some wonderful examples of metallurgical activities and how they were produced, because the ancient furnaces, rows and rows of them, they are all available, they have all been found, and there are pictures now, and some of them have become very famous ports, very famous sites. Now, you see, this is when I was talking about the earlier I talked about literary evidence. Now, we are talking about archaeological evidence. We have numerous excavations have revealed rich hoards of artifacts all over India. We are especially important, as I mentioned, is the Harappan port at Lothal, Gujarat coast. The thousands of metal artifacts, copper and bronze objects have been found from all over India in many places, because it spread from the northwest to rest of the India. And on the basis of that, today we know what all things were happening in India. Like I'll show you the picture of the copper furnaces. This is the kind of furnaces which are just maybe a foot or two high. The fragments of these ancient copper furnaces have been found in many sites in the Rajasthan region, and from the basis of that the drawing has been made. These are the drawings actually made from furnaces, ancient sites, as to how zinc was distilled in India. You had these retorts, and in these retorts, this is where the charge was there, zinc ore roasted and carbon, and zinc vapors came and condensed here. So, they were also sometimes called brinjals, because they look like brinjals. So, you see there is an escape route for gas, because the CO gas has to go out, but the zinc from the charge came and condensed all around here, all around the central tube. Now, they always used huge number of retorts in groups, often groups of 36 in a chamber, and there were two kinds. There were vertical retorts, and there were also horizontal retort. This is an actual site on a hillside. You see the retorts embedded are still there, and these have now become archaeological sites of great importance. This is retort walls of Zawar mines. So, this was very special technology of India, which was not available, and Indians somehow had managed to keep it very secret. They wouldn't tell anybody until 18th century. Nobody knew what was going on. Now the details of exactly how things were done for making copper or zinc, they are available now. They are available in the text, especially in people like Nagarjuna has very clearly written the steps to be taken, how to make what. Like the copper alloys are produced in small furnaces using crushed quartz about equal in weight of the ore, and nearly twice as much charcoal had to be added. The slag, mainly ferrite, FeOSiO2, which melts at about 1170 degrees, could be removed only if the whole charge was taken to about 1200 degrees. That is what I am saying. The copper melting point is 1083, but you have to run the process at about 1200 degrees to make sure that ferrite slag part is removed, and the ancient Indians are doing that. For producing zinc, sphalerite, zinc ore, it is ZNS, was mixed with impure dolomite, crushed quartz, and roasted first to make oxides, which were rolled into 1 centimeter pellets with some salt and carbonaceous matter, and they were heated in small retorts, each containing 1.5 kg in clay retorts, with the pictures I showed, with funnels like condensed tubes. Heating was external, temperature at 1250 degrees. Often cow dung cake was used for quick heating of the entire furnace, and after 6 hours 200 to 500 kg 500 grams of zinc could be produced in each retort. So, each retort produced maximum of half a kg of zinc metal. How do we know all these details? Again, there are extensive description and details in many ancient texts. Secondly, there are excavations today which have revealed all the retorts, some with their charges intact. So, people have taken out the retorts, analyzed what is there in the charge, some with zinc, Some before they were fired, they are all there, because as I mentioned, in the 18th century they were all flooded and they were abandoned. So, they have stayed as it is. Now, what happened actually to all that? Now, the decline was because of two reasons. Firstly, from 400 AD to about 11th century, the Zawar mine area was very active. Then Mahmud Ghazni, when he attacked India, he was devastating, and Al-Biruni, a traveller who had come from Persia at that time, has mentioned that by that attack he almost killed the sciences of the areas that he conquered, and people fled. But what happened is, many people became very secretive, and some continued their work, but would not let others know. For example, that zinc production continued, but even Mughals did not know much about them. Until 17th, 18th century, nobody knew about them. But then many people, skilled people also moved southward, which were then, there was no Muslim rule there, there was relative peace. So, the south of India acquired a very special expertise in the area of bronze and brass, and that continued, and that continues even now. There are people who are still making beautiful bronze castings, beautiful brass statues using the lost wax process, and that has continued for centuries. So, the statement by the Persian traveller Al-Biruni was, Mahmud Ghazni utterly ruined the prosperity of the country. Hindu sciences have retired far away from the parts of the country conquered by us. And it happened. They all fled south. And many artisans moved to southern states, but the art of brass making did continue in secrecy. As I mentioned, even Mughals were not quite aware of it. And Abul Fazl mentions in Aini Akbari more about Hindu Ashtadhatu, which supposedly contains copper, tin, zinc, lead, then gold, silver, and sometimes mercury added as an amalgam, but he doesn't write about zinc as such. By Ashtadhatu, some others meant that it had copper, bronze, brass. Very often bronze and brass, they were thought to be metals, lead, iron, gold, silver and arsenic. But clearly zinc was not identified by Abul Fazl. Anyway, so now I will end by giving you some pictures from ancient India of some artifacts. This is one of the oldest figurines made of a non-ferrous alloy, and the very famous dancing girl of Mohenjo-daro. Mohenjo-daro is now in Pakistan, but this is almost a symbol of India. The thick-lipped, snub-nosed aboriginal from southern Balochistan with bangles, armlet and stringed necklace with 3 cowrie shell pendants, bronze statues cast by some method. I do not know what that method means. Here is a brass object that was part of a chariot in submerged Dwarka, dated 1500 BC, off the coast of Gujarat. They have found now in the sea submerged walls. Obviously, they say that was the city of Dwarka, which got flooded and is now under sea. Lot of things have coming out. This has come from that submerged Dwarka. Now, this analyzes copper, zinc 10%, lead 1%. Though this must have come, this zinc must have come by cementation process, means copper filings added to roasted zinc core and heated to get this brass. This is a picture of just after the Harappa period and later period. the copper hoard sites, ancient copper artifacts dating 100,000 BC, 2000 BCs have been found from all over these places, huge, which means that it spread from the Rajasthan area all across northern India and towards the south also in later periods. This I have shown an ancient copper, these are the ancient zinc retorts. Now, let me end by showing you some beautiful pictures which speak so highly of not only our expertise in metal production, but also in craftsmanship. This is the upper, this is from the Gupta period, means middle of the first millennium. It is called the Gupta period. These are copper 73%, tin 5%, zinc 3%, which means at that time again that zinc was coming because it happened to be in the ore. And metallography showed lead at the grain boundary. The attractive image has triple folded neck, you can see the neck, the broad shoulders, the armlet and the headed bands, etc., 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 etc. Now, the beauty is not only that somebody produced a metal like that, but they had a method to cast a statue figurine of this quality. Here is one which is a 7th century AD, analyzes 73% copper, tin 2%, zinc 10%. So, it is tin, zinc, lead, iron. It is a strange kind of an alloy, almost becoming like an ostadhatu, but you cannot call it a bronze. It is more of a brass with little bit of tin. That is what perhaps gives it this color. But look at the beauty of this sculpture. Now, this of course, this is one of the many Natarajas that are made. It is considered by the experts to be one of the most artistic things ever created in world art. There are a lot of interpretations of this, but I would not like to go into the aesthetic aspects. I just want to tell you it is from South India, the Chola dynasty, 11th century AD, and one of the important large bronzes in the collection of in Madras Government Museum. It is made of bronze, copper tin. This is again early Chola period, another thing, Shiva, Nataraja rather, 950 AD. This is a Ardhanarishwara, half woman, half man. It is Chola period, 11th century. It is a close up profile. This is another thing from 1070 to 1125. From here you can see it looks more like bronze to me. Now, here is another very interesting kind of alloy, which seems to be very peculiar to India. Maybe it is there in the Middle East also. This kind of thing is called birdi ware, birdi, and a birdi ware is inlaid with silver and brass, inscribed in the rim. The base metal is high zinc, low copper alloy. So, it is a different kind of brass, very high zinc, low copper alloy, and on that they have inlaid of silver and brass. The thick patina is due to they treat it with some chemicals by KNO to give you some black marks, some oxidation of copper rich phase, a beautiful design. This is a birdi ware. This is also an Indian birdi ware. Now, I am giving you a random sample of some beautiful objects of art made of non-ferrous metals. If you go to Indian museums, especially if you go to South India, go to Madras, Bangalore, see the museums, you will be amazed at the kind of expertise we had in casting these figurines out of non-ferrous metals, bronze and brass. Now, first of all, Indians made those alloys, and secondly, from those alloys they made those beautiful things of art. So, India had achieved excellence not only in non-ferrous metal production, but also in using those alloys to make beautiful things, apart from other things for different kinds of uses which you find in Lothal. So, I think I will conclude this lecture now by saying that we have very briefly gone through the history of metal production in the world, and we have seen that from Stone Age we moved into Chalcolithic period, where copper was used with stone, like in Egypt and many other places, copper having been produced accidentally perhaps. And then if there were tin ores along with copper, we produced bronze. People learnt that here is something which is even superior to copper in terms of hardness, and initially they did not understand as to what it was, but they found that this kind of ore produces this kind of copper, which is better than the other kind of copper. And only slowly they began to learn that there was another metal in it. So, people identified tin also. Brass came much later. Brass of the kind what we know later. Initially, the brass was made by cementation process, which contained only small quantities of zinc. You take copper filings, heat with zinc cores, and some zinc will get reduced, and you will get a copper zinc alloy, but you will never get an alloy which has more than 9 or 10% zinc. So, it is not a very good quality brass. Very good quality brass was first produced in India starting from about 400 AD, because India had learned the process of distillation of zinc. They knew how to quench the zinc vapors in a retort. Now, a retort is a very special kind of device. It cannot be completely sealed, because when the roasted zinc core is being reduced by carbon, then carbon monoxide is being produced. So, it has to escape. So, you have to find a way of allowing CO2 escape, but not zinc vapor to escape, which means there has to be some outlet where, as the temperature drops, it must be in open air, and as the temperature drops, zinc vapors must quench to give you the metal, whereas the CO goes out. So, they had by trial and error, they have perfected the technique. They are producing zinc from 400 AD. So, India did have a very rich heritage in non-ferrous metal extraction. Unfortunately, when I talk about rich heritage in non-ferrous metal extraction, it is only the common non-ferrous metals: copper, lead, zinc, tin. Not so much of mercury also, although mercury they did produce. Mercury was extensively used in alchemy, in Ayurvedic medicines. But perhaps in China they produce many tons of mercury, because there was an emperor whose tomb has been excavated now. He actually created for him an paradise in which he was buried, and all that has now been excavated. Apparently, there was underground his tomb surrounded by rivers of mercury, and that was the legend, that it is not a bit of, there were actually rivers of mercury. Now, people thought it was a legend, but now they have found that the soil there really is very rich in mercury. So, they are producing, because they had whole lot of AGS. But India, of course, was always crazy about gold, and India was always importing gold through sea route, through land route. Somehow from Tibet a lot of gold was coming, because Indians were crazy about hoarding gold, and because they are crazy about gold, Indians are also crazy about zinc, because it looked like gold, and that is the reason why people like Nagarjuna spent the entire lifetime trying to produce zinc in large quantities. Well, I guess that should be enough about the history of metals in India, another world, and now I will go into the subject proper in my next lecture. Thank you.